So what I'm going to do first is I'm going to try to explain to you the basic concepts of geothermal heating and how it's applied to our model over here. So essentially how it works is the temperature of the Earth is at a constant warm temperature, and humans use that to their advantage. And they place inside these loops this liquid called glycol, or an antifreeze called glycol. So there are different kinds of loop systems. There's an open loop system or a closed loop system, and there are different kinds of closed loop systems. The first kind of closed loop system is a horizontal loop system, and here 5 to 6 foot trenches are dug and the loops are placed into them horizontally. The first kind of closed loop system is a horizontal loop system, and here 5 to 6 foot trenches are dug in and the loops are placed inside there. The second kind of a closed loop system is a vertical loop system, and here 150 feet pipes are dug into the ground and they're placed there. And the last kind of closed loop system is a lake or pond loop energy system, and here the pipes are placed into a body of water and the heat from the body of water is used to heat the home.
2, 1.
Now before I continue, I'd like to draw your attention to the thermometer here. So it's risen to 22.2 from its original temperature of 22.1, which shows that our system here is working. Now, I'd like to continue to explain how it works. So essentially, as I said, the glycol, the antifreeze in the tube, carries the heat from the ground up into this home. And here it goes to this heat exchanger or heat pump. And this fan here is used to distribute the heat that is gained from the ground and distributes it through the entire house, therefore heating the home.
Hi, my name's David, and you're probably asking yourselves, why did we decide to do geothermal technology? Well, one of the reasons why we decided to do this type of technology was to show how economically friendly everyone can be by creating their own energy without using outside resources such as coal, oil, and gas. Geothermal technology is used in single-family homes, all the way over to large corporate companies. Economically, you can save up to 70% in energy consumption using geothermal technology. This method relates to architecture due to the fact that it has decrease of harmful effects on the environment, as geothermal technology has no emitted greenhouse gases.
Hi, I'm Megan, and as David said earlier, geothermal is used to heat single-family homes, as in my house. So there are 2 types of heating systems in my house. One is the closed loops in the floor, which extract heat from the tubes that are buried in the ground outside the house and carry it to the floors in my house. The other is a forced air system, which extracts the extra heat from the fluid that's carried from the earth into the house and forces it through the house as in warm air. In the summertime, it acts as an air conditioning unit also, so geothermal energy can be used to heat homes and to cool them in the summertime.
Hi, I'm Naveen, and an example of a geothermal heating system is a Manitoba hydro place, which consists of approximately 280 wells underneath the building, which consists of closed loops, which has glycol liquid in it. And this glycol liquid transfers the heat from the ground into the pipes in order to heat up the building. Another example is the Orly Airport, located in France. It has not yet been installed, but it is said to have to provide approximately 30% of the building's heat.
Hi, I'm Ben, and I'll be explaining the physics in this model. Now, the key to this model is that the whole system is trying to get into a heat equilibrium between the pot, the pipes, and the air inside the model. Now, because of the constant high heat of the water, subsequently the pipes and the air inside the model will rise up because they're all trying to get into equilibrium. But also, because the fan is blowing heat off the pipes and distributing the heat into the air inside the model, the pipes will subsequently cool down and therefore take the heat out of the boiling hot water even faster. Now on a large scale, the heat inside the Earth is only 10 to 14 degrees Celsius. Now this is not a boiling pot of water by any means, but it will allow heating systems to take less heat from the outside air and therefore use up more energy trying to raise the temperature of the air to produce heating during cooler seasons. And during warmer seasons, it will allow for cooling systems to use less energy because it's a constant 10 to 14 degrees, and therefore it doesn't need as much energy to cool down the system. However, even though the heat is being taken from the pot in this small scale, it takes a lot of energy out of it. On the grand scale, the entire Earth has a lot of energy for it to be taken away, and the sun has constant radiation every day, so the heat that is taken from geothermal systems will therefore only take an infinitesimally small amount that has no practical use whatsoever. And so, as the heat equilibrium system gets into a final state.
Hi, my name's Eric, and our project is geothermal energy. We started off with plastic tubing, which did not conduct heat very well, so we switched to copper pipes and a coil to maximize the heat. And we originally used a heating coil that was only meant to heat up coffee mugs, which wasn't strong enough to heat our house. So we switched to a full-size heating coil. And then we originally used a glass jar that used to conduct the heat just like this, but the problem was it would get too hot and it would crack and it would break, so we switched to the metal pan. The way this works was the coils heat up, which heats the inside of the house. The fan blows the air throughout the house, circulating it. And the colored air we could have used to show the circulation of the air throughout the house a little more effectively. And we could have used a pump, like in the real situations, because they're closed loop systems, but because of the small scale, we couldn't do that. So we were restricted by just the scale, pretty much.
And keep that temperature in mind because it's going to be raising.